In this video, we're going to look at one of the other evaluation methods, which is uniform annual benefit or cost. In this video, we're going to cover four concepts associated with this. Converting all cash flows to dollars per year, which is the process of this uniform annual benefit or cost. The concept of repeatability, which we're going to talk about why when you have repeatability in projects, a good technique is the uniform annual benefit technique. Capital recovery concepts and equivalent capitalized equivalent, which is also related to present worth, but we'll look at this in this video. So first of all, converting all cash flows, the process of doing this kind of evaluation technique is we convert everything to an annual cost. So no matter what the cash flows are, we convert them to equivalent uniform annual cost or benefit. Now the little bit tricky thing about this is we're going to be going back and forth between annual cost and benefits. So the signs, the negative or the positives, are going to be changing a little bit depending on whether you call it a cost or a benefit. So you have to be a little sensitive to that when we're traveling through this video. The reason this is used quite a bit is this is often how people think. They think about an ongoing cost, like a rent per month or income per month. Lots of people think about that. We don't think about a one-time cost and then spreading that over the life. We think about this as ongoing. So this is a good method to use when you're trying to use some sort of common sense associated with it. So as an example, we take this initial investment of $3,000 that also has a benefit of $800 a year and then a salvage value at the end of $1,000. We're going to use an interest rate of 10% and we're going to convert this to equivalent uniform annual cost. Now the rules for deciding whether this is a good investment are the same as the rules for net present value, in that those with a positive annual benefit we will accept, and those with the highest positive annual benefit or the lowest costs are the ones we're going to, if we're choosing between alternatives, that's the one we're going to choose. So what we're going to do is we're going to look at the equivalent uniform annual benefit, and you can see the $800, that's already in an annual value. So we're just going to leave that there. Now remember when we were doing present worth, the value like the 3,000 was already in a present value, so we left that. But in this case, we want to convert everything to an A value. So the $800 a year is already an A value. And then we subtract from that the 3,000, but we're also going to convert that to an A value. So we're going to say find A given P at 10%, and we're going to do it for the full 6 years. And then in addition, we're going to take the ending value, the salvage value, and put it into an annual value. So we're going to take 1,000 times A given F, because it's a future value, 10% for 6 years. So then we just look up those factors in the table, and it ends up that the equivalent uniform annual benefit is $241 per year. Now this is greater than zero, therefore, it should be one word, this is a good investment. So that's how we go ahead and judge this. We convert everything to annual, and then if it's greater than zero, if it's a benefit, we go ahead and accept this investment. So another example is we're choosing between two testers, strength testers, tensile strength testers. One costs $4,000, a 10-year life, and an annual maintenance of $500 a year. The other costs $6,000, has an annual, is also a 10-year life, has an annual maintenance of $200 a year. The salvage for the first is $1,000, and the salvage for the second is $500. Use an 8%. So I have drawn these two alternatives, and I would just actually suggest that most of the time in problems that you use the visualization to help you to solve the problem. So I've drawn those two, and what I want to do is I want to convert them both to uniform annual cost using an 8%. And I'm going to use cost here and not benefits. So right now the signs of this are going to be reversed. So because this is a cost, the $500 is just an annual cost. And then the initial value of $4,000 I'm going to spread over for 10 years. And then the ending value is a negative cost because it's an income. And I'm going to spread that over 10 years. And that value, once I've found the factors, is 1,027. For the second alternative, I'm going to do the same exact thing. The 200 is a cost. the 6,000 cost is spread over the 10 years, and the negative 500 salvage value, because it is a negative cost or a benefit, is spread over the 10 years also, and that value is 1128. So we're going to choose alternative 1 because it's the lowest cost alternative. Now, this is an example of why you have to make sure that you know what you're doing, whether it's benefits or costs. We're going to move now into this concept of repeatability, which is a specialized concept that you can use with annual worth or annual equivalent uniform annual benefits or costs. So when you have unequal lives, if you have two alternatives that have different lives, it's actually better to use this concept. And I'm going to kind of try to walk you through the logic of this, and then I'm going to show you an example. So let's just say we have a simple investment, and then we have 2 years of benefits and a salvage value. This can be converted to dollars per year, right? We know how to do that, which we did in the other values. And when we're looking at repeatability, we can also take a lot of them and line them up. In this case, I have 4 identical investments lined up one after the other. And that too can be a dollars per year. And can you see that the dollars per year in both cases are the same, whether I have 1 project or 4 projects back to back? The dollars per year are all the same. So we can use that concept when we talk about repeatability. It doesn't matter how many times you line them up together, the dollars per year is always the same. So let's look at 2 alternatives. One is a 2-year life and one is a 3-year life. Now, if you remember in class, we looked at this with present worth, and what we did is we repeated it 3 times for the 2-year life so that it was an equal life of 6 years, and it was 2 times for the 3-year life project. So we wanted to define an equal time period, and we went ahead and did like back-to-back investments. And then in uniform annual costs, we can convert those also then to uniform annual benefits. But if you remember from the previous slide, the uniform annual cost is going to be the same whether we do it 1 project or 1,000,000 projects back to back. It's still the same dollars per year. So we always are going to try to choose the highest benefit, but we can actually skip a step here, and we can just calculate the uniform annual benefit from the 2-year project and the 3-year project, and then just compare those, because it doesn't matter whether it's 2 years or 300 years, it'll always be the same dollars per year. And we can choose the highest equivalent uniform annual benefit. So let's look at an example of that. 2 alternative investments have presented themselves. These investments are repeatable. Use an 8% interest rate to determine which is the best choice. Okay, so there's a Wigwam investment, which is $150,000, but the annual benefit $50,000, no salvage value. It only lasts for 4 years. The kite gym, on the other hand, is $190,000. It's $20,000 annual benefit and $10,000 salvage value, but it lasts for 20 years. So you're wondering which is the better investment. So all we're going to do here is all we're going to do here is go through the calculation of uniform annual benefit for the Wigwam and then also for the kite gym. So you can see I took the $150,000 and I spread it over 4 years. I took the $200,000, I spread it over 20 years, which is the life of the project. And the same for the salvage value at the end. So this calculate came to be $47.15, and this calculation ended up to be $8.58. So what we do is we choose the Wigwam has the highest equivalent uniform annual benefit. So we choose, this should say, that should be a K. We choose the Wigwam. So now we're going to look at the next concept, which is the concept of capital recovery. And I think this is another one of those concepts that was used because we didn't have calculators. So we wanted to kind of minimize the number of calculations we use. So this is another shortcut. But what it is, the concept is that lots of investments look like this, where we have an initial investment and then over some period of time, we have the salvage value. So lots of times an investment results in a salvage value over the life. So there's a shortcut that was developed, and I could go over the proof of this, but I'm not going to. So just have to sort of take my word for it, that equivalent uniform annual cost is equal to I minus S, A given P. So we take the difference between the investment and the salvage value, we spread it out over the life, and then we add to that the interest times the salvage value. This doesn't make much sense when I've never been able to kind of in my mind figure out why this makes sense. I know why it makes sense algebraically, but we just have to kind of trust this is a shortcut. Now the reasons it's a shortcut is that we can only have to look up one factor. So let's look at an example. This example we're going to look at doing kind of the way we usually do it, which is take the 5,000 and spread it over 10 years, and then take the 1,000 and spread it over 10 years, and take the difference in those two. We look up these factors and we get a 751. Now we're going to look at using this equation, which is, you'll get the same answer, but in a different equation. So in this case, we're going to do 5,000 minus 1,000, spread that over 10 years, and then take the interest rate times the salvage value. And we look up that one factor. See, there's only one factor we have to look up, where the previous one we had to look up two factors, and we get the same answer of 751. So this is another shortcut that's used sometimes in engineering economy. So the last concept I'm going to talk to you about today is an equivalent, a capitalized equivalent. And what this means is that if we have a infinite cash flow, a cash flow that's occurring every year forever, so n is infinity, and we want to convert that to a present value, what we do is we take the cash flow and we divide it by the interest rate when n is equal to infinity. And if we want to know what the annual cash flow is, we can take the principal and multiply it, the present value, and multiply it by the interest. So this concept is actually, in this equation, it's saying that you can take off interest from an initial investment. So take the investment times the interest. You can take the interest out forever and never get into the principal. And that's kind of a pretty important concept in engineering economy. So let's look at an example. So how much life insurance should you have if when you die you want your children to have $5,000 a month forever? Use a 6% compounded monthly interest rate. Okay, so I have this $5,000 forever, and I said the R is 6%, the M is 12, so that means the interest rate per month is 0.5%. I'm going to use the concept of P is equal to A divided by I. So that means it's A divided by I is $1 million. And that means I need to get $1 million policy. And that's how we would say, if I have $1 million now, I can then withdraw $5,000 a month forever, and I'll never get into the principal, and it'll never be less than. So the things we've covered today are converting all cash flows to dollars per year, and then repeatability concepts, capital recovery, and capitalized equivalent. So the equations that you might want to use are this equivalent uniform annual cost value, which is converting an investment and a salvage value to an annual equivalent. Or when n is equal to infinity, we can use the concept A is equal to P times